Here at BRE we have a particular interest in building quality. For some time we've been interested in the relationship between the quality of project information and the standards achieved on site. In a recent study we observed 38 projects made up of a variety of sizes and types of building in both the public and private sectors, traditional as well as the less conventional forms of contractor in use. BRE observers were stationed at each site for 2 to 3 weeks, where they had close contact with site management and the clerk of works, as well as full access to the project documents.
As one of BRE's site observers, I saw a disturbing number of serious quality problems. These were problems that involved failures of water penetration, unacceptable appearance, and also serious doubts about long-term durability. The majority of these problems originated in poor design, unworkable details, errors in information, and discrepancies between the various contract documents. Here is a very typical example of the sort of problems that cropped up. The architect and service engineer had discussed the need for an external door to the boiler house, and the architect had put this onto his drawing in the position he preferred. Unfortunately, the engineer, when designing the plant layout, worked from an old copy negative, which did not show the door. Following Murphy's Law, he located a main duct at low level across the doorway. The discrepancy showed up on site after the doorway was built. So this door here had to be inserted, and the original doorway round here bricked up to produce this rather weird, unusual architectural feature. And of course, significant extra costs were incurred as well. Here's another problem which took over a week to resolve, with lots of quarrels on site. The contract documents were brought into disrepute, and there was no happy ending. When the shuttering was removed, the architect was upset with the finish of the in-situ concrete. It had been marked on his drawing as superfine finish. The structural engineer, who had written the specification, had just included a general clause which didn't really cover what the architect had in mind. Both gave their verdicts on the quality of the surface, neither very kind. It was only then that the contractor pointed out that the bills also included for painting their concrete with a textured cement paint. What, he asked, was the point of a high-quality finish? Everyone realised for the first time that the design team, in the usual pre-tender rush, had failed to coordinate the project documents. There were a lot of red faces. In the end, the architect decided to omit the paint and accept the poor quality finish.
There is very strong evidence that the most effective means open to the designer of obtaining good quality is to get project information to the contractor in good time. This diagram summarises the results of the BRE investigations. We graded the quality of the information supplied to site into 5 categories, from excellent through to very poor, and correlated these with the quality of work to be seen on site: good, average and poor. As you can see, the good quality information coincided with the good quality work, and where the information was poor, the incidence of poor quality work was high. The terms of reference of our study were to look at the causes of quality problems. We didn't set out to discover their cost, but nevertheless we were very much aware that progress on site was often disrupted by late or inadequate project information. This often led to delays, uneconomic working and claims for additional payments.